need to bypass authentication entirely during early development, without sacrificing the ability to add real security later. We'll use FastMCP's DebugTokenVerifier to instantly accept any token while maintaining the exact same auth interface your production code will use. This lets you prototype freely now, then swap in JWT or OAuth verification later with zero code changes. From FastMCP, import FastMCP. From FastMCP server auth providers debug, import DebugTokenVerifier. Hash accept all tokens, useful for rapid development. Verifier equals DebugTokenVerifier. MCP equals FastMCP. Name equals development server. Auth equals verifier. This demonstrates the debug adapter pattern for authentication systems, specifically a bypass verifier that simplifies development workflows. The pattern provides a controlled way to disable or mock security components during testing without requiring full authentication infrastructure. What makes this distinctive is its ability to maintain the same interface as production verifiers while removing all validation requirements. The approach works by implementing the same token verifier interface, but replacing cryptographic checks with a simple pass-through or custom validation logic. This maintains the separation of concerns between authentication and business logic, allowing your application to run unchanged while testing. The debug verifier can either accept all tokens unconditionally or apply lightweight validation rules that match your testing needs. This pattern matters because it eliminates authentication as a development bottleneck, letting you focus on core functionality before implementing security. It's particularly valuable in early prototyping, CI/CD pipelines, or when integrating with systems that haven't finalized their token infrastructure. The trade-off is clear. You gain development speed at the cost of security, which is why this should never be used in production environments. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI-callable tools. It serves as the main entry point for defining and exposing Python functions as tools that AI models can invoke. From FastMCP server auth providers debug, import DebugTokenVerifier. Imports DebugTokenVerifier, a development-only auth provider that bypasses token validation. This enables rapid iteration by accepting all authentication tokens, but defeats security never used in production. Hash accept all tokens, useful for rapid development. Verifier equals DebugTokenVerifier. This instantiates a DebugTokenVerifier that accepts all authentication tokens, bypassing real validation. Critical for rapid development when security isn't the priority, but defeats production-grade auth requirements. This is the debug provider pattern. Swap it with a real verifier like JWT before deployment. MCP equals FastMCP. Name equals development server. Auth equals verifier. This instantiates the FastMCP server with debug authentication. The name parameter identifies this instance in logs and metrics, while auth equals verifier enables the debug token provider we configured earlier, bypassing real authentication for development. This is the standard initialization pattern for FastMCP servers. Debug token verification pattern. The debug token verifier bypasses real authentication during development, accepting any non-empty token by default while still providing full claims injection for testing authorization logic. This pattern should never be used in production as it accepts tokens without validation, creating a critical security vulnerability. The verifier's custom validation, callable, enables everything from simple prefix checks to async database lookups, making it adaptable to any testing scenario.
The token that that verifies nothing, verifies everything.